Okay, in this equation, it doesn't look too bad, right? It's just a sine squared term, some sines and cosines. What you want to do is, what you always want to do with equations, you try to factor it first. You try to get everything on one side equals to 0, that's done already, and then turn it into something that looks like this. Okay, factor times factor equals 0, because in that form, you can pull the solutions out pretty easily. Okay, so go ahead and try to factor it. I'll wait. Spoiler, right? This, you can't factor this. There's no greatest common factor. There's no way you can factor it like a trinomial. Okay, you could waste a lot of time trying, but you're not going to get anywhere. This one requires the use of trig identities to solve. You need to change something in the equation, make a substitution of some kind, so you can kind of unjam yourself and get it towards factored form. The question is, which one of these trig identities should we use? I'm not going to look at the double angles because these are all single angles. Not that that's always a hard rule, but when you don't see a 2 omega, that's a hint that you don't need the double angle identity. Sometimes that's not true, but I'm going to start by guessing maybe we need to do something with the Pythagorean identities, because I see a squared term right there. And exponents, like squared, are a bit of a giveaway that this might be a Pythagorean identity that we're going to use. Okay, so the Pythagorean identity I'm going to pick is actually the Santa Claus one. Okay, the old sine squared plus cosine squared equals 1. And I'm going to get rid of sine squared and replace it with cosine squared. And we'll see how that's going to be useful. You might be thinking it's not a great trade, but watch this. 1 minus cosine squared omega plus sine omega cosine omega minus 1 equals 0. Well, now look what happens. The 1 over on the left, way over here, is going to cancel out with the minus 1 over there. And now the equation only has cosine and sine terms in it. You're going to be able to factor this thing just using a GCF. And I've done that plenty in other videos, so I'm not going to repeat that here. I'll leave that for a little bit of an exercise for you on your own. But what I am going to do is I want to modify this equation. Pretend that minus 1 were not there. I want to talk about a special case that you're going to see in some of these problems, where you factor something out, you look at this and say, oh, GCF, sine omega, right? We pull that out. And you get what's left behind is sine omega plus cosine omega. Okay, right? Go ahead and multiply that back out and prove to yourself that this is true. Okay, I just turned that into the top equation that I started with into this factored form. And at this point, now we have two factors times each other. That's great. I can start solving this one. Sine omega equals 0. Well, that means omega equals 0 and pi. Okay, and I got that from what I know about the unit circle. Remember, where are the sine values equal to 0? Those are the y-coordinates. There they are, 0 and pi. So next, we look at the second factor, the one on the right, and that says sine omega plus cosine omega equals 0. And at first, I don't know what to do with this, right? I can't factor it any further. I don't see anything that really jumps out at me. I don't know what the sine plus cosine values are on the unit circle. I only know sine or cosine values. So what you can do is go back to the identities. This is what you always do when you're stuck. Go to the identities and find one that's useful. I'm going to pick on quotient identity because I know I can't use Pythagorean identities. There's no squared terms here. So use the cosine or use the quotient identity. We're going to do that by this. Sometimes you just have to play around with these things a little bit until you notice something like that. Subtract cosine from each side, divide by cosine. You get sine omega over cosine omega equals negative 1. Now, sine omega over cosine omega is just tangent omega, right? That's the quotient identity at work. So now we can use tangent omega equals negative 1. Okay, this is the quotient identity. We can use tangent omega equals negative 1 to find some more angles. And those are going to be, remember, tangent functions equal 1 or negative 1 on these diagonal lines. Okay, so those 45-degree lines. And negative 1 is in quadrant 2 and quadrant 4. So that's going to be what? That's, I think, 3 pi over 4 and 7 pi over 4 from the looks of it in my poor drawing right there. So there are your answers. You have 4 angles to solve this equation. And you might just want to check domain restrictions, make sure there are not any extraneous solutions here. But sine and cosine are very nice trig functions. They don't produce any d and e's. Okay, so you're good from that point of view.